up in lesson 6.7, where we left off yesterday. And in your class, we got A done. So I want to do a few more examples from this top part, and then we need to look at the bottom part. And then if we have time, you'll have a little bit of work time at the end. We'll see. No guarantees there. So, okay, let's review. We're given the function y equals 2x plus 8. Now, before we get started, help me out. What is y equals 2x plus 8? Okay, y equals mx plus b. And what is y equals mx plus b the graph of? A line, yes? It would be a line that has an intercept of 8 and a slope of 2. So, like rise 2, run 1 type thing. Okay, so it's a line. Okay, so in order to find the inverse, what is step 1? Switch x and y, right? X becomes y becomes x. So instead of y equals, I'm going to say just x equals. Just switch the variable, not the pieces with it. Instead of 2x plus 8, I'm going to say 2y plus 8. Okay? Now, after we switch x and y, what was the next step? Solve for y, yes? So, I have x equals 2y plus 8. What is my first step in getting this y by itself? If it's 2y plus 8, to move that 8, since it's plus 8, I'm going to subtract 8. If I subtract 8 on one side, subtract 8 on the other side. So, what is x minus 8? X minus 8. On the other side, we have 2y, and then the 8 minus 8, cancel. So I have 2y equals x minus 8. Okay. Final step to solving for y.
Would you divide it by 2?
Yep. Divide by 2. If it's 2 times y, we're going to divide by 2. If we divide one side by 2, divide the other side by 2. Now, there's a couple of different ways we can do this. X minus 8 divided by 2. One option is to leave it as x minus 8 over 2. Another option is, and if I take that 2 and I divide it into both pieces, it's x divided by 2 minus 8 divided by 2, which is 4. Now, x divided by 2. What's the invisible number in front of x? 1. So if you think of this as 1x over 2, do you see that as a 1/2 x minus 4? Okay. And so if this is 1/2, y equals 1/2 x minus 4, what is this the graph of? This has a slope of 1/2 instead of 2. Now, I forgot, we don't leave it as y equals. How do we note that it is the inverse? F inverse of x, right? So F inverse of x equals x over 2 minus 4. And if you want, you could say 1x over 2, but you don't have to. There's no plus minus because I didn't take any square roots this time. If you leave it as x minus 8 over 2, that would most likely be okay. Okay. Now, the reason I didn't here is because if I say, what is the graph of y equals x minus 8 over 2? I'm going to get a lot of blank stares. I struggle getting a decent answer with 1/2 x minus 4. But I'm more likely to get something out of 1/2 x minus 4 because you hear 1/2 x minus 4, hopefully you're thinking mx plus b. When I say x minus 8 all divided by 2, that mx plus b doesn't necessarily equivalate in your brains. Okay, so that's the main reason I did it. Because I wanted you to think, oh, this is a line. It's a line with a slope of 1/2, so it's just not as steep of a line. Because a question you have to often answer in homework. Is this a function? Is this a function? Yes. Would it pass the vertical line test? Yes, I can draw a vertical line. It's just going to cross it once. So yes, this is a function. And that, more than anything, is why I forced you guys to, I forced you to change it to 1/2 x minus 4. Although I didn't really force you because Reese did change it. So, you know. But why I suggested you change it. Okay, questions on that one? Did you have a little success when you did it before I started?
No. Yes.
No.
See, it's either you're right or you're wrong.
I made it to the x minus 8, but then I forgot to divide the x by the 2, so I ended up with just, I put 2x equals y.
Okay. Okay. Well, let's improve. Let's try example C. Y equals square root of x minus 2. Okay, step 1. Switch x and y. So instead of y equals, I'm going to say x equals. Instead of square root of x minus 2, square root of y minus 2. Okay. I got to solve for y. Y is under a square root. What am I going to do? Yeah. How do you get rid of a square root? You raise it to the power of 2. If we raise the right side to the power of 2, we got to raise the left side to the power of 2. So what is x raised to the power of 2? X to the power of 2, x squared. Okay. Here's the part you have to actually think about. The square root of y minus 2 squared. When you square a square root, you get whatever's under the radical, right? So this is just y minus 2. Okay, keep solving. If it's y minus 2, we're going to add 2. If I add 2 on one side, add 2 on the other side. So the y minus 2 plus 2 will cancel. And I have y equals. What about x squared plus 2? X squared plus 2. Officially, I need to put this in inverse notation, which just means instead of saying y equals, f inverse of x equals x squared plus 2. And then the big question. No, did I ever take the square root? So I don't need plus or minus because I never took a square root. Is it a function?
I
feel like there's guessing going on. Let's not guess. Okay. Y equals x squared plus 2. Can you visualize that graph? What is y equals x squared? A parabola. The plus 2 just takes it up 2. So y equals x squared plus 2 is that shape of graph, a parabola. Is that a function? Yes. It passes the vertical line test, right? You can draw a vertical line and it only will ever touch the graph once. So yes, it is a function. Okay. Now, another thought, if you want, and I'll talk about this more on the next one we're going to do. If you're saying, okay, Mrs. Sargent, I know you're going to tell me I should have known that graph, but I didn't. Okay. Plan B, if you don't know what a graph looks like. Try plugging values in. Okay, if I plug in, say 2. 2 squared is 4, plus 2 is 6. Is there any other answer I could get after I plug 2 in? 2 is only going to get me an answer of 6, right? What if I put in negative 2? Okay, negative 2 squared is 4, plus 2 is 6. Is that okay?
Yes.
In other words, if I get 2, 6 and negative 2, 6, is that okay? Yeah, what is it that can't repeat? The x. Is it okay for y's to repeat? As long as they're with different x values. So that's another way, is to start testing values. And see, now if you get a value, if you plug in 2 and you get 2 different answers out, usually because of a plus or minus sign, that's when it's not a function.
It's okay if it's like 2, 6, and 2, 6, right?
Or, yeah, if they're the same, it's fine, yeah. Okay, does that help a little bit? Okay, I told you we aren't doing all of these. Let's jump down and do F. I'm going to skip D and E. We're going to jump to F. And what I tried to do, and I think I did a pretty decent job, is I'm trying to match up with some ones you're going to see in homework. I could be overlooking something, but I think I did a fairly decent job. So F. Okay. What's my starting step? Switch x and y. So instead of y equals, x equals. Instead of 8x cubed, 8y cubed minus 1. Now we're going to solve for y. It's 8y cubed minus 1. What do I do first? Add 1. If I add 1 on the right, add 1 on the left. What is x plus 1? X plus 1 equals 8y cubed. And then the minus 1 plus 1 will cancel. Okay, if it's 8y cubed, how do I solve for y? Don't worry about the 3 yet. Divide by 8. If it's 8 times y cubed, divide by 8 first. Now, I talked about in that previous one, we can do the 8 divided into both pieces, right? Or we can leave it as a fraction. I'm going to leave it as a fraction this time. Okay, and this time I don't see any advantage to making it x over 8 plus 1 over 8. Last time I saw an advantage. So, and 8y cubed divided by 8 is just going to leave me with y cubed. So I have y cubed equals x plus 1 over 8. How do I finish off solving for y if it's y to the third? You cube root. If it was y squared, we took the square root. Because it's y to the third, we're going to take the third root. Or in other words, the cube root. If I take the cube root of one side, we take the cube root of the other side. What's the cube root of y cubed? Y. Easy enough. What is the cube root of x plus 1 over 8? Okay, so we have some options here. And I'm hearing different options being set out. Okay, so one option is to just leave it. And it's not the most simplified option. So like Math Excel would probably bulk at it. But one option would be to say the cube root of x plus 1 over 8, where it's all under the radical, yes? In terms of x plus 1 is the sum. I can't take the cube root of those because they are added together. So the cube root of x plus 1 has to stay that way. However, denominator, do we know the cube root of 8? The cube root of 8 is 2. And so what we can write this as is the cube root of x plus 1, and then all over 2, where the 2 is no longer in the radical. And of course, if we put this in inverse notation, I'm going to say f inverse of x equals the cube root of x plus 1 all over 2. Okay, your favorite question. Is it a function? I don't necessarily expect you to know what this one looks like, which is good in some instances if you're sitting there saying, man, I haven't known what these look like anyways. Okay, so if you don't know what they look like, start plugging in some values, right? So, for instance, if I throw in 0, random number, 0 plus 1 is 1. The cube root of 1 is 1 over 2. Am I going to get any other answer besides 1 over 2 when I plug in 0? No. Okay, if we put in another number, if I put in 1, 1 plus 1 is 2, cube root of 2 is, I don't know, some decimal, divided by 2. Am I going to get another answer than that if I plug in 1? No, I'm only going to get that one answer. If I'm only getting one output, one answer, is this a function?
Yes.
It is a function. Now, I did just realize in talking there at the end, something I forgot to mention as we were solving. And we took the cube root of both sides. Obviously, we did not need to put a plus or minus because I didn't put a plus or minus. Why did I not put a plus or minus? Okay, so because it was a cube root, we didn't put a plus or minus, yes? Anytime it's an odd root, you don't need the plus or minus. Why did we put a plus or minus back on example A yesterday? It was a square root, okay? It was an even root. And because of that plus or minus, if you glance back there, notice that plus or minus made it not a function because we would get 3, 2, and 3, negative 2. Okay? Okay, you're going to see a lot of solving, finding inverses, and answering whether or not they are functions today. Yes?
Okay, this might be a really dumb question, but I am a little bit confused about it. So on C, when it's like, it was just x equals square root of y minus 2, why did we put parentheses with the exponent of 2, and then on F, whenever we wanted to cancel out the same thing, we put a cube root?
Okay, the difference being, I think I understand what you're asking. So here, we used the power of 2 here, right? And that's what you're questioning. Because it doesn't say it right here, but if this is the square root of y minus 2, what's that invisible number in here? If it's a square root, it's a 2. And so we're always using the matching power to that. So since it was a square root, we raised it to the power of 2. Whereas down here, you're talking about probably this step right here. It was y to the third. So to get rid of a power of 3, we have to do a cube root. In other words, it's all about getting them to match. If this had been y squared, I would have done a square root. If this had been y to the 5th, I would have done a 5th root.
So to cancel out a power, you do a root, and then to cancel out a root,
Yep. Does that help?
yeah.
Okay. No, good question. Okay. We got to do example 3. You ready? Okay. Example 3 talks about using composite functions. We talked about composite functions back in 6.6. This was Fogg and Goff. Okay. So this is good practice because some of you didn't care for Fogg and Goff and all of that. So we get to keep practicing with this. Now, the point that's being made here is if you have a function and its inverse. So if f and f inverse are inverse functions, then two things are true. The composition of f inverse composed with f will always equal x, and reverse it. F composed with f inverse will always equal x. So the idea here is that if a function and an inverse are truly inverses, okay, no mistakes made or anything, that when you put them together, they will always equal x, or they will always equal whatever their input is. So in this case, x. Okay? Now, that's one of those things that, given a situation, you could just state an answer. It's also one of those things where sometimes they'll say, okay, prove that this function and its inverse, prove that they are inverse of each other. And then we can use this to prove that they are inverses. Now, I'm going to take you through a couple of steps here to kind of help you understand this a little bit. We've got to start back at the beginning, though. Given f of x equals 5 minus 2x. Well, part A asks us to find f inverse. Do we know how to find f inverse? Didn't we just do that on the 4 examples above? Yeah. Now, I might need to state, to help us out, f of x equals 5 minus 2x. What do you know f of x is? F of x is equivalent in the original problem to y, correct? So as an original problem, this is y equals 5 minus 2x, correct? Just a reminder there. Okay, so to find the inverse, what do? Switch x and y. So instead of y equals, I'm going to say x equals. Instead of 5 minus 2x, I'm going to say 5 minus 2y. How do I solve for y? Okay, so to get the 2y by itself, we're going to move the 5. It's a positive 5. So I'm going to subtract 5. X minus 5 is x minus 5. On the other side, 5's cancel, and I'm left with negative 2y. How do I get y by itself? It's negative 2 times y. Divide by negative 2. If I divide one side by negative 2, I divide the other side by negative 2. We can make this 2 fractions or leave it 1 fraction. I think I'm just going to leave it 1 fraction, honestly. We'll be okay. So negative 2y divided by negative 2 leaves me with y. X minus 5 divided by negative 2. X minus 5 divided by negative 2. Now, officially, if I want to give official notation, instead of y, what should I say? F inverse of x. X minus 5 divided by negative 2. Okay, that was part A. We had to do part A before we could do part B. Part B asks us to find f inverse composed with f of x. Which, if you remember how I did fog and goth, this means we're doing f inverse of f of x. Can you tell me the answer before we work through this problem? If f and f inverse are truly inverses, what's f inverse composed with f of x going to equal? F inverse composed with f of x is going to equal x. Now, my job is to prove that to you. Okay, but if this is all done right, it should equal x. That's the trait that I'm trying to show you. I don't like the word trait, but I can't come up with the word I want. So, okay, guys. Now, f inverse of f of x. That means I'm taking f of x and I'm putting it into f inverse. What is f of x? It was given as 5 minus 2x, right? So what we're going to do is we're going to take that 5 minus 2x, and I'm going to put it in to F inverse. What is F inverse? But what does F inverse equal? Didn't we find it over here in part A? F inverse came out to be x minus 5 divided by negative 2, correct? So if we're trying to find F inverse of 5 minus 2x, every place I see an x, I'm going to replace it with 5 minus 2x. Or think about it this way. F inverse of x is something minus 5 divided by negative 2. So something minus 5 divided by negative 2. What am I putting in for something? Five minus 2x. Because we're putting in whatever f of x is. And f of x was 5 minus 2x. Now do the cleanup. What is 5 minus 2x minus 5? 5 minus 5 is going to cancel, and I have negative 2x, still divided by negative 2. What's negative 2x divided by negative 2? X. What did we suggest this answer would be? X. Okay? So depending on the situation, if you're just asked what F inverse of F composed with F of X is in homework, like on Math Excel, you don't necessarily have to do work. If you understand this rule, you can just say X. Now, if it's asking you to prove it and you have to show your steps, well, that's a different story. Show your steps. And in that case, I'm talking about, like, I don't know what I'll do on the test yet. Now, we're going to work C out. But what's the answer that I'm going to get for C? Not X this time. Because what's my input? 2. Think about it. If F composed with F inverse of X is equal to X, well, F composed with F inverse of 2 is going to be equal to 2. Now, can I prove that to you, please? Rhetorical question. So, F composed with F inverse is F of F inverse of 2. Of course, we start where? On the inside. How do we find F inverse of 2? You use F inverse, which what is F inverse again? Something minus 5 divided by negative 2. What's the something I'm putting in this time? 2. So 2 minus 5 divided by negative 2. What's 2 minus 5? Negative 3 divided by negative 2. What's a negative divided by a negative? Positive. So could we also say that's positive 3/2? Now, that was me doing F inverse of 2, and I got 3/2. What do I still have to do outside? We still have to do F of 3/2. What was my F function? Five minus 2 times X. What do I use for X now? Three halves. So 5 minus 2 times 3/2. Yes, it's a fraction, but I promise it works out nice. How do you multiply 2 times 3 halves? 2 over 1. What happens when you multiply 2 over 1 times 3 over 2? Twos cancel, and you have 3 over 1. So it becomes 5 minus 3. What is 5 minus 3? 2. What answer were we expecting to get? 2. Okay? It's just plugging in the numbers and doing the math. Okay? And we have to keep working with the compositions. I know that's a weakness. We're going to keep working with it, which is why I'm forcing you guys to practice with these. Okay, your homework is lesson 6.7, Math Excel. You have 9 minutes. You could actually get a little bit done in 9 minutes, believe it or not. Okay?